Hello everyone, this is Mohammad Sabi number Proho back again with another video about pandas and datasets. So today we're going to talk about the imbalance dataset issue. Sometimes our dataset has imbalance issue which creates a risk of wrong prediction. So what unique value, suppose 950 does not have diabetes and 50 has diabetes, which is not balanced, right? Because the difference is very high. It shows what kind of unique values are there. So by using the unique function on our dataset of class, we can see that it has one unique values and it doesn't have zero common values. So by using non-unique function, it shows how many unique values are there is from the previous unit's length. Let's see. It has two unique, right? So it shows the array and it shows the length of the array. Now we will use group by function by its size, and by resetting the index to count, we will print the value of how many are there or how many types are there. So it will show that our class 0 has 200 and class 1 has 320. So we can understand, or we can find out the difference between two classes. Now, to solve this issue, we will use reducing the major class samples to match the minor class in the case of imbalance, which is undersampling. Now, to solve this issue, we will use scikit-learn utilities resample. So we know that our first array is majority and second array is minority. So you will use df of class, which is in an array in majority, and other one is minority. And we will sample it from the length of the minority. Now, as we are undersampling the data, which means that we are downing the size of majority, we will use majority downsample variable and resample by using the resample function from scikit-learn, where the majority function will replace by false by the number of n samples. So n samples is the length of minority. So we are matching that number, and random state is just a state of the function parameter. So now it is a balanced dataset by using concatenating the minority to majority downsample. Now if we run this, our dataset is undersampled. Now if we count the values by group by, you can see that both of them are 200 and 200. At first it was 200 and 320, now it is 200 200, which is balanced. And moving on to oversampling. At first we matched the minority with the majority by cutting down the majority and making them equal. Now we'll increase the majority by adding the number into the minority. So for that we will use imblearn.oversampling and import smooth function. So we will drop or delete the whole column with remaining feature and then target the class into y. So x is the dropped function and y is the added value. So by using the smooth function, we will resample x and y and fit it by using the xy values. So oversampled data is data frame, x resampled and changing into the x column, and oversampled df class is the y resampled. Now if we run the function and let's say count the values, as you can see that the minority has now become the majority or matched the majority of numbers. So by using these two methods, we can handle our imbalance dataset issue, because most of the time it creates a issue for our dataset or prediction, and by using this we can handle the imbalance in the dataset. Now sometimes we have unrealistic values in our dataset, like for example in this data set our has an age which is 600. So a human being cannot be in age of 600, which is why we need to find out where it is located. Because of this age, it can create problem in those values, right? As it is a medical prediction or medical predictor, so we need to be very concise and precise about this because it will help us to detect various diseases, right? So outlier is an anomaly value like age equal to 600 because of mistake. To handle this, we need to find it. So, there are two methods, which one is finding from figure, and another is finding from statistics, and another one is finding the z-score. So z-score actually helps to identify in which index it is located. So from the figure, we can just draw a plot, and it will draw the plot, right? So as you can see that from 600, there is a small value there. So we know that it is the anomaly value of the data set. As you can see that I labeled the scores and age, and it is showing me the exact anomaly of the data set. By using this, we can easily find out, but we need more concise presence. So we will just use describe. We can see categorical has been transformed into numerical values, and we can see the max and minimum value to find the anomaly. So as you can see, the max is 600. So it's easily founded by us by using the describe function. And now by z-score approach, which is a more reliable source, and it helps us to get the particular index. So z-score, we will the z-scores equation is the main age minus the mean divided by is standard deviation. It helps us to find out the exact index, and if the z-score is more than 3 or less than minus 3, it gives us an outlier, because an outlier in layer is supposed to be within the range of minus 3 and 3. But when it crosses that line, it is an outlier or counted as an outlier. To find it, we'll just run through the loop by finding each z-score, and it will just help us to find out the okay, sorry, I didn't run the function. So yeah, as you can see that z-score are defined here, and we'll just run through the loop. Yes, as you can see that I have an outlier which is 20 point something. So it is more than 3, a huge gap, which is why it is a perfectly indexed outlier. So the index would be of this function is 4. As you can see, it shows 4. So by just exact value of the index would be 600, right? We didn't see where it is located, but just using the outlier function or z-score, we found out the exact location of that edge. Now we will just replace it by the mean. So it is replaced by the mean, and now it's changed into the mean 49, right? That's very easy, very easy. And sometimes we have an duplicate samples in our data set. So it is another issue. So to find that, we need to just use the duplicated value or duplicated function, and it will show us that how many duplicate values are there. So it is just showing us that duplicate value here, 84, 110, and 160. These are all the duplicate values here. As you can see, 35, 35, 00, right? So by using df drop duplicates, it will drop all the duplicates values, and it will just show me no duplicate value. As you can see, there are no duplicate value, and the length is 252. So almost half of the values were duplicates, and by dropping those duplicate values, we have shaped our dataset into a more optimized dataset for our prediction, right? Because think carefully, right? That duplicate values don't add much for our prediction or mathematics, which is why we drop them to get a more precise or more concise data. or more conscious prediction for our machine learning algos. So these were the main usage of pandas, and there are other libraries I will show you in my next class. So that's it for today. Thank you for staying with me.